One of Orbiter 2's bonus pictures was a shot of the crater made by Ranger 8 when it impacted the moon. The freshness of the crater was determined by measuring the brightness of the volcanic rock around the crater. Originally concentrated and dark in appearance, the material was now powdered and brightened by the force of the Ranger collision. Lunar Orbiter not only provided outstanding photographs of the moon, it also helped improve our earthbound measurements of the moon's shape and its gravitational field. Micrometeoroid sensors on board discovered that a spacecraft orbiting the moon has no more chance of being hit than one in orbit around Earth. Measuring radiation, Lunar Orbiter 1 experienced 2 solar flares after completing its photography. Flares that would have spoiled its pictures had they occurred earlier. Lunar Orbiter 3 photographed this great 400-mile-long fault, half as deep as the Grand Canyon, and on another part of the moon, a mountain towering 6,500 feet from the floor of a crater. Other orbiter photographs reveal many craters filled with what is apparently volcanic debris. Here is a wealth of material for continued study by geologists and other scientists. For example, the crater Copernicus is one of the most prominent features on the moon. Until not long ago, this photograph, taken through the 120-inch reflecting telescope at the Lick Observatory in California, was the best available. This is Copernicus as seen by Lunar Orbiter 2. 60 miles wide, 2 miles deep, the crater dominates the face of the moon. Thoth, the keyhole-shaped crater in the foreground, is about 13 miles across and nearly a mile deep. Thoth is 33 miles from Copernicus. Much of this distance is covered with debris blasted from Copernicus by the impact of a giant meteorite billions of years ago. Rounding the back shoulder of the moon, one orbiter got an exceptional shot, the first photograph of Earth seen from outer space. From afar, Earth seems shrouded in clouds, much as Venus has always looked. To scientists, this photograph suggests that Venus may not be hidden beneath a perpetual cloud cover. A TV camera close enough to photograph Venus may find holes through which to see this planet with greater clarity. Who knows what a closer look at the evening star will bring? What answers may be found? Or what new questions man may have to ask about the nature of the universe? Other surveyors have touched down near the Landsberg crater in the Ocean of Storms and in the Sea of Tranquility, pressing their unmistakable footprints into the lunar surface. Like their predecessor, these surveyors took a good look at themselves and then turned their television cameras on the lunar countryside. One of the most unusual features of Surveyor 3 was its surface sampler. A 5-foot-long arm with a hand-sized scoop. This device was designed to dig into the soil to determine bearing strength and other characteristics. It dug several trenches in the lunar crust. It dumped samples of lunar material on its footpad, allowing close examination of the freshly disturbed soil. In other tests, the scoop was deliberately dropped on the surface, and pictures taken of the resulting dents and cracks. Another surveyor experiment used this alpha scattering device to determine the chemical composition of the lunar soil. At one point, surveyors' cameras interrupted their look at the moon to record this event, an eclipse of the sun by the Earth. The most important scientific conclusion drawn so far from all these photographs is that the moon's ancient surface is still slowly undergoing change. This has been caused mainly by the jarring impact of objects hitting the moon. But whatever the cause, the moon is not, as we thought, a perfectly preserved relic of the geologic past. Lunar Orbiter has extended the mapping of the moon to the far side so that features there could be accurately located. And it also surveyed many important scientific sites. These pictures of the moon's polar areas disclosed striking new details. This is Oriental Basin on the extreme western edge of the moon's disk and stretching 600 miles in diameter. The mountains surrounding the basin are among the most massive on the moon, rising some 20,000 feet above the surface. Other areas of interest to scientists have been explored. What are the changing red spots that have been seen in Aristarchus? What makes the crater's walls so bright? What kind of erosion created the river-like channel in the Alpine Valley? Was it volcanic? Or was it, as some conjecture, the result of water on the moon's surface eons ago? What is the explanation of Cobra head? How was it formed? Why are there certain color differences in this region? Near the Harbinger Mountains lie a number of curious craters with sinuous channels extending from them. Scientists will try to deduce what could have happened on the moon's surface to account for them. Because of the astonishing detail of pictures like these, the yield of information is great. For example, this rock is 75 feet across. From the picture, it is possible to tell that it rolled downhill some 900 feet, scraping away the lunar topsoil. This rock is only 15 feet across, but it too left a trail that can be clearly seen. Oblique photos of the Copernicus crater would seem to exclude it as a suitable landing site for a manned spacecraft. But a look at other Copernicus photos taken from a nearly vertical perspective reveals several promising possibilities, particularly here in the northwest area. And surprisingly enough, these lunar photo missions have shown scientists views of Earth no man had ever seen before. This is the first photograph of the nearly full planet from 215,000 miles away. It will provide additional information on the amount of sunlight reflected by Earth. Lunar Orbiter has successfully surveyed 99% of the moon's front face and significantly increased high-resolution coverage of the far side. These pictures are likely to be the source of lunar surface information for many years and should contribute to a fuller understanding of the moon. If many other questions are still in doubt, some of the answers may already be in our hands. Examination of these photographs is not complete, and already they've produced miles of data tapes to be processed. And additional information is being returned so rapidly that it will take years to evaluate it all. In 1950, astronomer Fred Hoyle lamented that man had seen all he would ever see through even the most powerful telescopes. It was time, he said, to leave the Earth. Within 100 years from 1950, Hoyle hoped man might be able to launch a rocket with a radio-operated camera and see the Earth as it looks from outer space. Much more has been done. The doing wasn't easy. The plans didn't always work. But when they did, they took us beyond the dreams of the 50s to a point where, within 20 years of Hoyle's modest wish, 2 Americans will actually land on the surface of the moon. In the meantime, there will be more great pictures like this now famous photograph. When this happens, Hoyle predicted, when we can leave Earth with a camera and move out into space, it is certain to make marked changes in our whole outlook on life. The apple is still there.